Good afternoon, ladies and gentlemen. I would request everyone to please take your seats. And since this is a formal conglomerate, I would request everyone to keep your mobile phones in the silent mode so that during the presentation, no speakers actually gets distracted. Also, I would request while the session goes on, please do not loiter around the alleys so that the speakers actually concentrate on the topic. Once again, I would request everyone to please be seated. Take your seats, please. Thank you very much. This is Serene Sarkar, and of course, going to be a host for this particular session. And I would like to take the opportunity to welcome all you fine people, distinguished dignitaries, eminent speakers, and respected chair to the second International Conference on Green Hydrogen India 2024, of course, at Bharat Mandapam, New Delhi. To make India the global hub for production, usage, and export the green hydrogen and its derivatives, this will be contributing to India's aim to become Atmanirbhar through clean energy and serve as an inspiration for the global clean energy transition. The topic that we're going to be discussing today is optimization and indigenization on electrolysis processes for renewable energy integration. And the concept about this particular session is green hydrogen produced through water electrolysis powered by renewable energy presents a promising pathway to reduce GHG emissions of H2 production over conventional fossil fuel-based methods. To enable India to achieve its ambition of 5 million tons of domestic green hydrogen production by 2023, India may need to install 45 to 90 gigawatt of electrolysis capacity depending on technology, efficiency, and utilization. Electrolysis process presently faces challenges related to efficiency, cost, suitability for integration with the intermittent nature of renewable energy sources as well as industrial process integration, which will need to be addressed to enable a rapid adoption and scale up. Further, a key imperative is also development of an indigenous supply chain which can offer multiple benefits such as self-sufficiency, cost reduction, and potential to develop India as an attractive manufacturing hub for electrolyzers and components. Once again, ladies and gentlemen, it is my privilege to welcome all you fine people. Asatoma ma sadgamaya, tamasoma jyotira gamaya, brittur mamartam gamaya. Lead us from the unreal to real, from darkness to light, from mortality to immortality. Ladies and gentlemen, of course, present everyone here and to the mass of India, we are definitely heading for a brighter and a better future. It is my privilege to welcome all our eminent speakers on the dais right now, and of course, our respected chair. I would like to invite our respected chair, Mrs. Anvesha Thakker, to join us on the dais. Anvesha Thakker is currently working as a partner and lead renewable energy in KPMG. She has advised public and private sector clients and multilateral organizations on policy, strategy, financial and commercial related initiatives in the energy sector. She has more than 23 years of extensive work experience, and in her career, she has worked on several marquee projects in the renewable energy, hybrid storage, EVS, RDF, and green hydrogen space in areas of policy and regulatory advocacy. procurement of energy, undertaking business, market intelligence, business plan, financial modeling, feasibility analysis, cost reduction, transformation. Ladies and gentlemen, we say in every lady, we might see Durga. So yes, of course, salutation to the women power. And here we have Mrs. Anvesha Thakker. Thank you very much, ma'am, for joining us. I would now like to invite to join us on the dais our eminent speaker, Mr. Shekhar Kashalikar. He is the CEO of John Cockerill Greenko Hydrogen Solutions, a joint venture between Greenko and John Cockerill. John Cockerill Hydrogen is a leader of electrolyzer technology, and Shekhar, and of course his team, is currently developing its electrolyzer manufacturing facility in India. Over the last 30 years, he has been associated with industrial energy equipment business. He has helped to set up manufacturing units for power, steam, heating, cooling equipment, heat recovery, energy efficiency, and industrial energy transition in his passion. Ladies and gentlemen, please put your hands together for Mr. Shekhar. I would now like to invite the dais. Our next eminent speaker is Shaji John, is the Senior Vice President of Ohmium, a green hydrogen technology company, where he leads business development and sales since June 2022. He also oversees global EPC and development initiatives and serves as a board member of Ohmium India Operations Private Limited. An electrical engineer from NIT Bhopal with an executive MBA from SP Jain, Mumbai, and a certified project management associate from IPMA, Switzerland, Shaji has secured landmark deals like NTPC 400 MW green hydrogen projects. He has cultivated strong partnership with global companies such as Shell, Hero Futures, and AMP Energy. Please join me welcoming Mr. Shaji. I would now like to invite on stage Mr. Kalyan Bhanja, a chemical engineering graduate from REC, now which is called NIT Durgapur. Joined BARC in 1990 with over 34 years of experience in nuclear processes and engineering. He excels in proof of concept demonstrations, process scale-up, and project execution. His notable achievements include developing technologies in hydrogen energy, electric hydrogen production, and high-purity monocrystalline silicon preparation. Additionally, Mr. Bhanja is involved in safety and regulatory assessment of hazardous chemicals like hydrogens and trichlorosilane. His expertise and dedication has significantly advanced nuclear engineering and safety standards. Inviting the dais to join our eminent speakers list, Mr. Siddharth Gupta. Mr. Gupta is the Chief Executive of L&T Electrolyzers Limited, a position he has held since January 2024. Prior to this, he served as Chief Executive at L&T Horden Private Limited, as a General Manager and Head of Sales and Tendering at L&T MHI Power Boilers Private Limited. With extensive experience in the power sector, Siddharth has been actively involved in policy formulation, interfacing with government agencies like the CEA, Ministry of Power, and MNRE. His contributions have significantly impacted the evolution of India's power sector. Mr. Gupta, thank you very much for joining us. I would now like to invite to join us the dais, Mr. Bhushan Chithale. Is the Head Strategy of Partnership at Thermax Limited, focusing on green hydrogen technology and carbon capture. He leads business development and new initiatives, collaborating with OEMs, developers, and government bodies. With over 14 years of experience, Bhushan has rich experience in evaluating new business opportunities and crafts strategies for growth, particularly in Southeast Asia and Africa. Can we have a big round of applause for Mr. Bhushan, please? I would now like to invite to join us, the dais, Mr. Siddharth Mayur. Mr. Mayur, a visionary leader for first-generation social entrepreneur, founded H2E Power Systems in 2009 to provide clean, green, and affordable energy. His company is pioneering green hydrogen electrolyzer and fuel cell technologies in India. With over 2 decades of experience, Siddharth has significantly contributed to renewable energy, real estate, and advanced battery technology. He's also the founder of Mayur Re-Energy Solutions and Empower GmbH, driving innovations in solar, wind, biomass, and fuel cells. Ladies and gentlemen, presenting to you Mr. Siddharth Mayur. I would now like to invite to join us in the dais, Mr. Vaidyanathan Nagarajan is the Managing Director of TNI Private Limited, and he is the seasoned C-level executive with over 30 years of experience in senior management, including P&L responsibility and M&A. He has led diverse teams across India, the Middle East, Africa, APAC. Currently, he is Managing Director of Thyssenkrupp Nucera India, a role he took on September 2023. Previously, Mr. Vaidya was the Managing Director of Thaino Nippon Sanso, India, where he achieved significant business growth. His career includes successful tenures at BASF, Air Liquide, and Gulf Cairo, driving growth in both domestic and international market. Ladies and gentlemen, can we have a big round of applause for our chair and of course the eminent speakers. Before we start this session on optimization and indigenization of electrolysis processes and renewable energy integration, we have a report and which we're going to be launching right now, and the report will be launched by GIZ on implications of power requirement for green hydrogen production on the production system, on the power system. And to talk about GIZ, a German development corporation, and the report assessing the impact of green hydrogen production in India's power system. And this is by Indo-German Energy Forum along with CEEW. This paper analyzes the impact of large-scale renewable energy integration of India's power grid to meet the green hydrogen production target of 5 million tons per annum by 2023. So I would request representing GIZ to be on the stage and launch the report, please.
Good morning, ladies and gentlemen. So, Indo-German Energy Forum, along with International PTX Hub, has commissioned this study along with its partner, CEW, which primarily assesses the impact of green hydrogen production in Indian power system. As it has been clearly pointed out that India's RE is going to play a major role in terms of bringing green hydrogen dream to fruition. So that's why the Indo-German Energy Forum commissioned this study, and the study actually determines the optimal renewable energy and electrolyzer capacities and assesses the impact on grid flexibility, transmission, and storage requirement to manage grid operation with green hydrogen production. So the analysis models, as it will be detailed out in a presentation immediately after, it discusses on the various modes that is possible for green hydrogen integration into the RE system. So I would like to, I believe on the dais, everyone has an official report, but I will also invite the authors of the study, Mr. Rudhi Pradhan, Ms. Sanyogita Satpute, and Ms. Disha Agrawal to please come on the stage and join the DICE member for the official launch. Thank you. And of course, sorry, for MNRE representative, Mr. Anubhav, please. Sorry, sir. Yeah.
The report on assessing impact of green hydrogen production on India's power system.
Thank you. Thank you, everyone on DICE. And ladies and gentlemen, I would like to invite for the presentation, Mr. Rudhi Pradhan, who will take us through the key findings of the study and, of course, discuss on the major implications of power system requirements for green hydrogen production. Thank you. Over to you.
Hi, good afternoon, everyone. I'll just give you the key findings. I know the panels are here. So basically, in the initial session, we heard about the ministers saying the ambitions of green hydrogen means what is the nation's commitment to achieve the green hydrogen target and how the green hydrogen is an important element to decarbonize the entire economy. So I think this is a perfect segue of this report to study means what it would require to incorporate this green hydrogen demand in the electricity grid. So that's why we have studied this, assessing the impact of green hydrogen on India's power system. I'll just quickly run you through the study motivation, key insights of the study, and we'll present with you key findings on recommendations which the study provides. So if you see on the first slide, we have seen that the RE generation, in the left-hand side, the map shows about where the RE generation are presently there. So RE generation are presently concentrated in a couple of the 8 states, whereas when we are seeing the green hydrogen demand, which is on the right-hand side of the map, the green hydrogen demand is coming in a more dispersed manner. So what is required? It requires the renewable energy integrations to meet this green hydrogen demand. And hence, we are trying to answer key questions from this study, like what will be the efficient and cost-effective approach to achieve the green hydrogen production target? As Abhishek mentioned, what is the optimal combination of RE and electrolyzer capacity to meet our 5 million ton target? What will be the impact on grid flexibility, transmission, and storage requirement? So basically, this is a modeling study. We have done to find out all the answers. We have done 2 modeling. One is the first capacity expansion modeling we have done, where we have assesses what is the optimal resources, RE resources required in different states to meet the state-wise green hydrogen demand. All the data are there in the report itself. And then secondly, what we have done a production cost simulation modeling to understand if that much RE is coming in that state. So what will be the impact on the power system generations? What will be the impact on grid flexibility? What will be the storage requirement? Do we need more transmission capacity to evacuate the renewable energy? And so on. So to do this, we have done 2 scenarios. One is the business as usual scenario, where we have considered 28 EPS electricity demand without green hydrogen load. And then we have modeled green hydrogen scenario with 2 modes. So basically, we have considered around 300 billion units of additional electricity is required to meet this green hydrogen load. That we have also done in 2 scenarios, you can see, 2A and 2B. So green hydrogen demand with ISTS support and the green hydrogen demand without ISTS support. So what does it mean? For example, with ISTS support means we are using the transmission infrastructure, interstate transmission system to wheel power from one state to the other states. Whereas without ISTS support, we are not using the transmission system. There the state need to deploy its own renewable energy capacity to meet its own green hydrogen demand. So these are the 2 scenarios which you have seen. Now I will give you the top line findings which we have got from the study. We are seeing that India need 135 gigawatt of renewable energy capacity to meet this 5 million ton of green hydrogen demand. Solar capacity of around 51 gigawatt, wind of 84 gigawatt. The distribution is given in the map itself, how much capacity is required in different geographies. And to incorporate this green hydrogen demand, we are seeing that the peak electricity in the power system will be increased by 67 gigawatt. So in 2030, as per the EPS report, we are seeing that 342 peak demand would be there. But if we incorporate this green hydrogen electricity demand, we are seeing that the peak electricity demand will increase to 409 gigawatt. The second finding is about how much electrolyzer is required. It is 74 gigawatt of electrolyzer we are seeing to require to meet this green hydrogen demand. And also we are seeing that because of this green hydrogen load to incorporate in the grid, the flexibility requirement in the grid will become fourfold. So presently, if you see, we are having a net load flexibility. So net load means the entire load minus the VRE generation. So the net load flexibility is in the range of around 250 megawatt per minute. It will increase to the range of around 1100 megawatt per minute by 2030 with green hydrogen load. So fourfold increase in the flexibility would be there. And the right-hand curve shows you how the electrolyzer is operating. The electrolyzer is operating, that shows you the maximum daily hydrogen load, how the electrolyzer will operate. It is ranging between 74 gigawatt to 45 gigawatt of electricity. And as we know that electrolyzer have an inherent characteristics of flexibilization, means it can ramp up and ramp down, and it can operate in a wider load range areas. So we are also proposing that these electrolyzers should be identified as a potential resource for flexibility with CERC should do it with having proper compensation mechanism so that it will encourage the electrolyzer developers to help in the grid management as well. I'm being asked about the time. I will be very short now. So the next finding is that the storage requirement is getting reduced by 6 gigawatt. In 2030, we are seeing that 44 gigawatt of storage is required to manage the grid variations and to reduce the curtailment within 5%. This storage requirement, 44 gigawatt, will reduce to 38 gigawatt if we incorporate green hydrogen demand. Because of this additional demand, most of the VRE which would otherwise be curtailed will be used in meeting this green hydrogen demand right now. So that's why we are seeing the battery storage requirement reduced by 6 gigawatt. As I said, what pathways should India embark on to meet this green hydrogen demand? We have done two comparisons, one with utilizing the ISTS support, one without the ISTS support. If you are not utilizing the ISTS support, for example, if you are not wheeling the power from, for example, if you require any power in Odisha and if you have excess power in Gujarat, if you are not using that power to wheel from that Gujarat to Odisha, then we are seeing what impact it will have. We are seeing that the renewable energy capacity requirement will increase by 10 gigawatt more. Initially, we are having 135 gigawatt. For this case, we require 145 gigawatt of 145 gigawatt of renewable energy capacity. The cost of hydrogen will also increase around 14% from 3.6 USD per kg to 4.1 USD per kg. The storage requirement will increase by 3 gigawatt. And also we are seeing that additional renewable energy capacity is required in the state of Punjab, Uttar Pradesh and Haryana. We are seeing that most of the curtailment is happening in the northern region. So if you are using the ISTS support, this curtailed renewable energy is enough to meet the green hydrogen demand of these three states. But if you are not using the ISTS support, we need 5.3 gigawatt of additional capacity in these three states to meet their green hydrogen demand. As I said, the investment requirement for this green hydrogen ecosystem is coming to be around 10.6 lakh crore. 29% of this investment to the electrolyzer capacity, rest 71% to the renewable energy capacity. And these are the figures which says how the benefits, what is the benefits with ISTS supports and without ISTS support. Last slide. This is about recommendations. We have given 4 recommendations which need to look upon. So first is identify green hydrogen hubs to guide national and state transmission planning. So we have seen, in the report, we have demarcated the areas, how much green hydrogen production would be there and how much renewable energy capacity would be there in each of the states. So considering the land availability, water availability, green hydrogen hubs can be determined in those states, and CEA can use those informations to develop perspective transmission planning to evacuate renewable energy power to those green hydrogen hubs in the identified states. Also, we propose to expand the interstate transmission system GEC scheme, Green Energy Corridor scheme, where the central is providing financial assistance to strengthen, to augment the intrastate network of the states. So this is the first recommendation. The second recommendation, as I've said you, to recognize electrolyzer as a flexible resource under the CERC ancillary services regulations. Means a proper compensation mechanism need to be find out with consultations between the ministries and the industries and other stakeholders. The third one is about to develop grid connectivity standards. Since we have seen in the last decade that when more and more renewable energy capacity were coming, it is very much vital to maintain the grid flexibility and the grid safety also. What CEA has done in their grid connectivity standards in 2007, they have come out with standards for renewable energy generator. So similarly, in this decade, we are seeing when more and more electrolyzers would be coming, we require grid connectivity standards for electrolyzers. Last one. And the last recommendation is about to facilitate the establishment of industry-led consortium to pilot large-scale grid connectivity projects, green hydrogen projects. Yeah, so I'll not take much more time. You can download the study from this QR code, and we would be happy to hear your views. Please write to us if you have any comments, and we would love to hear your feedbacks on this. Thank you. Thanks for you.
Thank you so much. And now we are heading towards the optimization and indigenization of electrolysis processes for renewable energy integration. And to chair the entire session, I would like to request Mrs. Anvesha Thakker, the partner lead renewable energy, KPMG India, to take over. Thank you, ma'am.
Thank you so Hello. Yeah, thank you. Thank you so much for that. And congratulations to CEW and GIZ for launching the report. Without much ado, we're going to move on. We are a little constricted on time. So sorry if we are going to be a bit rushed. Apologies to the panel. I'm going to start off with a very quick context setting. India, as per statistical review of World Energy 2024, the primary energy consumption is one of the fastest growing in the world at 7.3% annual growth rate. A significant part of this energy today is being met through imports of oil, gas, and even coal. Nevertheless, India has a bold ambition to become energy independent by 2047, and that too in a sustainable manner. Renewable energy, we are doing a lot. Hydrogen, we made a very, very early start. And this is a very significant resource for the different characteristics that we have heard of since morning, so I'm not going to repeat it. But what is particularly important is to dive into this sector with a lot of consideration to how we can indigenize the supply chain. This is important not only because we should not be subject to supply chain vulnerabilities, which we have seen in other clean tech side, but also because here is an opportunity for India to be a major manufacturing hub and an alternative frontier to countries like China, when the whole world is looking at diversification of supply chain. It's easier said than done. We need to address a lot of things, right from cost to localization of components, capabilities, and above all, we also need to focus on the integration side, some of it, what we heard today on the renewable energy, but equally important on the demand side. How do we integrate with the requirements of continuous process industries? They're all the things that we need to now look at as we move forward into implementation. I can't be more delighted to have such an eminent panel of speakers from corporates and institutions, which today are literally at the forefront of developing the manufacturing sector in India. Welcome to the panelists, and we look forward to a great discussion on this. I'll start off right away with Mr. Kashalikar. How do you see the potential for India to develop as a major manufacturing hub for electrolyzer and components? And how do you see the opportunities and challenges in this regard?
Yeah, thank you, panelists. I think the one word answer is exciting. We have seen so many numbers since morning that I don't know whether it is 70 gigawatt or what gigawatt. But I think there are two aspects to it for manufacturing aspect. One is having a local large market is very, very critical for doing any great, good manufacturing activity, because manufacturing builds on feedback from customer, improvement in product, improvement in supplier. Second aspect is, if you look at electrolyzer or hydrogen production system, then the Indian industry is, I would say, very well versed with similar type of equipments. We have a large pool of MSMEs who are really good at machining. So we have milling, drilling, turning operations done very well, which will help the various steel-based components in electrolyzers, right? We have in the electrolyzer system electrical components, and we have companies which have already done really well. We have international companies as well as homegrown companies working on transformer, rectifier, and the entire thing. So that's not really a challenge. Those companies have really reached global scale as well as competitiveness. The third portion is about the hydrogen separation units of electrolyzers, where multiple companies in India working under oil and gas sector have been making skids, making systems, exporting it to the Middle East, to the global standards of oil and gas companies. So I would say this supply chain's familiarity with similar equipment is there, and this will be a real plus for Indian manufacturing. We ourselves have manufacturing John Cockerill in China, Europe, and USA. And we are still putting one more manufacturing in India, because we clearly see India has a potential to be the global lowest cost producer of electrolyzers, integrating our current industry, MSMEs, as well as certain places. And you asked about challenges. Yes, there are certain components like large nickel plated components. The supply chain is not developed in India yet. And that's where initial investment have to be made so that we have the entire value chain covered. There are certain technology items like membrane. I think let's take step by step. Maybe in the initial period, they may need to be imported. But there are multiple companies working. You have people from IIT, NCL labs, where we are doing basic research on, ultimate better materials. So I am really positive about India becoming a hub for manufacturing. Initial challenge remains demand, because we have talked about so many gigawatt. But when the bankers ask me, when I go to loan for my factory, how many electrolyzers were sold last year? And the answer is 0. Okay, what was it before? It was 0. So I think this is something new, which we need to look up for a sector. And this is unique, because if I want to put up a solar panel plant, I can show them so many solar panels have been imported and therefore market exists. For hydrogen electrolyzers, this is a really, we are ahead of time with market. And I think that is one of the challenge. I'm sure, my panelist is going to add more and more, but overall very exciting for manufacturing in India. Thank you.
Thank you, Mr. Kashalikar, especially for bringing out the financing point. We talk a lot about financing challenges when it comes to projects, but I think we equally need to look at the financing challenges on the manufacturing side. Mr. John, you're from Ohmium. Again, you have a global view on how you see the strengths and challenges in India. I would love for you to come in as well.
Thank you. It's not working. Thank you, ma'am. I think we just heard him saying that we are ahead of market in terms of demand. Actually, this may be different from what we have seen in the solar industry, that the manufacturers are ready, but the demand is still yet to be seen, right? That's the challenge the country is facing, not only this country, but across the globe, our experience is that in US also the market is slow down. In Europe also it is not great. It is moving, but not to the scale what we expect. So as a manufacturing company, what we see is that India is the best place. So we have actually created our global base in Bangalore. We have a 2 gigawatt factory already operating, right? So 3 reasons why it is so. Number one, very good government policies. Unlike what we have seen in solar, where India missed the bus for solar module manufacturing, whereas we took the learning from the wind industry, where today India is almost self-sufficient for the wind. I think this time government of India took a very good action to push local manufacturing of electrolyzer, and so is the case that we are ready in terms of manufacturing, but we are waiting for the demand to come up. This is the reason number one. The reason number two is that great entrepreneurship response, right? Government of India came up with PLI scheme tenders, and I saw almost like 30 odd companies have bid for it. And out of that, maybe 10 has got it. So almost like 3,000 megawatts of electrolyzer manufacturing is committed by these entrepreneurs, which is again a great response. So that is the second reason why we believe that it is a good base for manufacturing. Third, we heard just now that India has a great resource potential when it comes to the manufacturing of electrolyzer. When we see it as a product, we see it in 3 parts. Number one, it's almost similar to automobile. Number two, it is matching with power electronics industry. And these 2 industries are very matured in India. Number 3 is the electrolyzing per se, the stack, which actually splits the water into hydrogen and oxygen. That is where the technology and the skill has to come in. And that also we found that good amount of research and development and design engineering skill set is there in places like Bangalore. That's why we have set our base in Bangalore. So these are the 3 reasons why we believe that India would be the right place to fight and compete with the mighty manufacturing hub in the world. And India can become the number 1 manufacturer in the world for electrolyzer. This is point number 1. Challenges. I will just pick up 2 challenges. Number 1 is, obviously we see that some of the supply chain components, we have to wait for some time to be developed, like whether it's membrane, platinum group metal, electrode and cathode coating, etc. That is one. And we heard about the second challenge of demand. We are waiting for the developers, EPCs, the governments to come out with the demand for the electrolyzer. That's it from me.
Thank you, Mr. John. And hopefully with the recent aggregation tenders that we are seeing from SECI, that will be a signal to unlock the demand, because I do agree that demand unlocking is the main thing that is going to get the industry to take off. I would like to turn to Mr. Bhanja, and for those who are not aware, BARC is indigenously developed a prototype of electrolyzer. We are very proud to say that, and it's actually at a 1 megawatt scale already. So that's a very real indigenous effort on our part. So I would really like to dig a little deeper here on the component side and take your perspectives on where do you see the real challenges as far as indigenization of components is concerned, especially as we are looking to scale up.
Thank you, madam. And thank you, organization, for inviting me, at least for this kind of forum. Basically, there are 3 verticals are required. Though in hydrogen energy, there are 4. Here, there are, I will say, 3. One is academia, second is industry, and third, developer has to be there. So this is BARC is coming as a developer only. And for actual manufacturing, we are depending on industry, and academician is doing their own job. They are not going to, basically now R&D is converted into RD&D. Last D is for demonstration. So we are working from R&D to up to demonstration part. That's why it has been taken up. We have taken up this activity for some other work, but when hydrogen, this demand came up, so we thought, why not, we can use the same technology, or rather extend the same technology for green hydrogen production, because this is the only method of green hydrogen production. So BARC, whatever we have done so far, mostly alkaline. So actually there are 3 types of electrolyzer, which is more or less matured, I can say. One is alkaline, of course, I can say TRL level something 8 to 9 right now. Similar is pure water, but pure water only acidic side, PEM side, proton exchange membrane based, not that way anion exchange membrane base is developed. That is maybe 5 to 6 TRL level it will be there. And third is of course high temperature steam electrolysis. So there of course it is somewhere matured in, I would say, 6 to 7 TRL level, not beyond that. There are a few manufacturers worldwide, but India also there is some developmental stride, but still so far my understanding or my knowledge is concerned, it is totally on imported cell. So as it is told that Indian industry is geared up, industry is having everything. Even sales also in the Indian industry is making, Shekhar has developed this PEM cell, and that was Eastern Electrolyzer is making that. So it is not that we don't make this kind of cell. Only thing that the point is there, we have to be more focused, more energy efficient, and reduction in cost. That is the thing we have to do. We need not to, we need not to start from scratch. Things are already established. It is done, it is doable. Only we have to be little bit focused how to increase the energy efficiency and reduce the overall cost. So our goal is Atmanirbhar Bharat, and for that it should start with make in India, made in India, with Indian concept, Indian supply chain, as well as Indian technology. And of course, that is by Indian industry or for Indian industry. And of course, it should be, the technology should be global standard. It has to be global standard. We have to meet, otherwise it is not going to sustain in the open market, because such a demand is there, such a industry is there. As madam told that what in BARC, what we have done, we have tested all the 3 types of electrolyzer, that is SOEC, PEM as well as alkaline, but alkaline is much more matured. We have gone up to 1 megawatt prototype. I will not say 1 megawatt cell, because number of cell, because scale up, when we are going for scale up, there are 2 dimensions. One is increase the size of the electrolyzer, the diameter, and increase the length. Length is nothing but number of cell we can stack together in a single unit. So right now what we have gone, equivalent to 1 megawatt, that is around 2 kilowatt, 1 kilowatt per cell we have manufactured, rather developed, and it has tested, it has worked fine, and it is 100% indigenous. I would say 100%, because that diaphragm also made up by our own technology. Of course, it is very close to zircon, which is well known in the industry, but it is not zircon, it is our own diaphragm, but it can be easily replaced by zircon or any other things. That is one of the aspect. And different modules are there, and all the components, basic component is there. There are 3 basic components. One is diaphragm, where we are heavily dependent on outside sources, but it is manufactured to some extent. It is manufactured, but PEM, of course, PEM, there is not a single diaphragm. So far my knowledge is there. Maybe Ohmium will be able to comment is better. It has to be, right now it is only Nafion or equivalent, Sustinion, etc. It is there, but it is still imported one. But of course, for alkaline system, this zircon equivalent diaphragm we could able to manufacture, and with using that diaphragm, other 2 things are bipolar plate and of course electrode. Electrode is normally pure nickel, and for our system we have produced, and bipolar plate we have used SS, but it can be anything nickel coated also, that is possible. So all these technologies are developed. Coating technology is also established. It is not difficult to coat. Nickel coating is not difficult here. It can be done here very conveniently, whatever required, because required coating thickness hardly maybe 50 micron, not beyond that. So it can be done. And with that, I can say 100% indigenization is possible. It is probably done. Optimization, of course, we have to little bit work on it so that it is little bit energy efficient, and cost has to be competitive. That's it. Thank you, madam.
Yeah, no, thank you. Very, very heartening to hear that we do have the capabilities. But I think probably the industry will need to work with the supply chain, with the vendors, and work with them on the specifications and get to the requirements and work on R&D as well to improve and optimize, as you just said. I'm wondering, Mr. Siddharth Gupta, if, from L&T's experience in setting up your gigawatt factory, What are some of the additional points you want to talk about in terms of component?
Yeah, so thank you, Anvesha. From an L&T's perspective, we've come a long way in terms of indigenization also. Our supply chain has indigenized to a great extent the technology which we possess. I would say two items. Mr. Bhanja mentioned that the first one is the membranes, and the second one is the electrode assembly. So when you talk about a membrane, the performance of a stack is dependent on this membrane, and hence it is extremely important as a component that the complete technology is tried and tested. That is point number one. The second point is in the electrode assembly, for every OEM who's there, the electrode technology is different. So what I would say is that in terms of the conventional technologies, it is available in India, but however, the latest technologies, which is say, the foam-based or the mesh-based electrodes, is something which is still not available in India. So these are the two areas where I feel we have to work on as a country. And I would propose the following. I would like to quote China in terms of when they are a global manufacturing hub, where their manufacturing constitutes 27% of their GDP, and how they've done it is, if you see the industry's thermal power plant, or John was mentioning about the solar sector, it is done by developing the component level network and then coming to the sort of the main assembly. So the whole infrastructure is tuned such that even you have the equal capacity of the manufacturer or the component manufacturers available by the time that, say, the electrolyzer manufacturer is started operating the unit. So this is one thing which is very important for us. We have to develop at the ground level the same component suppliers of a similar capacity as to what we contemplate. So in India, if you're talking today that, probably the existing capacity is a gigawatt and we plan to be 12 gigawatts in the next 2 years, then do we have the infrastructure in place, or that scalability is going to become an issue, is a question which I want to put forth across. And the other thing is actually, identification of the gap matrix between the component suppliers where the technology is not available, and to tie it up and to take it to a logical end. So these two are sort of the suggestions which I have. Thank you.
So obviously, as a consultant, I can see the graphic coming right before my eyes on the gap analysis, and a very structured way of going about really figuring out that where are we, where do we need to go, and what is the step to be taken to get there. But yes, absolutely, Siddharth, I think. So let's just switch gears and talk about beyond AWE and PEM. And Mr. Bhanja alluded to it. He spoke about SOEC. But let's really understand what's going on globally and what are the technologies that are coming into play and why. And I would really like to invite Mr. Siddharth Mayur, founder and ED of Homi Hydrogen, who is looking at various technologies and is probably very well placed to answer this question. Siddharth.
Thank you, Anvesha. It's been a very energy-filled day since morning. So, there's so much of energy we feel all around. I think talking about electrolyzer technologies, we all talk about either indigenization or the supply chain, or we are talking about the gigawatt scale that we are putting together. I personally believe that we have to look at electrolyzers on a per industry basis. So I was talking to my team in the morning while we were on the flight that there has to be a matrix as to if you're talking about steel, then what electrolyzer technology would fit there. It's not a one size fit all thing, and it also is not that sasta mil gaya iske liye better hai. It's not like that. So it's not always the cheapest that wins, and I hate to use the word cheap. It's not the inexpensive that wins. You have to always look at what your end utility is, what is the pain point of what you are looking at, and therefore different technologies. So I would not say PEM is bad because it has a platinum, but PEM has a utility in a specific industry segment, and that segment could be a few gigawatts per annum. So we are not talking about small. Whenever we are talking electrolyzers, we are only talking about multi-megawatt projects. They are never small projects. If you look at alkaline, of course, is well established. It's the big daddy, and alkaline is not new to India. 1964, we had the first alkaline producing green hydrogen on Bakarnangal Dam, on the hydro. So again, green hydrogen also is not a new story to us. So then you look at anion exchange, or there's another technology that we have developed called AMSE. So these are all different technologies solving a particular pain point. You come to solid oxide, Bhanja ji also mentioned about the technology. Very interesting technology if you're looking at different processes. So, and I'm just, opening up a different discussion here that for different processes, you need different pressures. We are also talking about alkaline. I was talking to somebody yesterday who's developed alkaline with a 50 bar pressure that is coming out. Maybe that is very good for a particular process. If you want to make methanol out of it, then a 40 bar pressure is very good. If you want to use it in the steel industry, 1 bar pressure is what the steel industry uses. So if I'm producing at 40, then I have to bring it down to 1. So might as well use a technology that is producing at 1 bar pressure. If I'm producing ammonia, which is, the talk of town right now with the big ammonia tenders, I need hydrogen at a higher temperature. I need hydrogen at a 60 or 70 bar pressure or something like that. So we have to really look at the end application, and then the end application decides what you need. It is just like your automobile, for example. You cannot use a normal truck in a mine. You need to have a mining truck. You need to have a dump truck there. So these are different areas that we also as a country need to look for, because in India itself, if you just look at the domestic demand, and I'm not really looking at the refineries as a demand sector, because that's a known thing. And then that at some point in time will become a reality. But ammonia is big. You look at the steel industry, it is very big. If you really look at the food value chain, right from the farmer, warehousing, food processing, to the plate that comes, food that comes on your plate, and then the waste processing, there is so much of application for hydrogen or hydrogen-based derivatives, whether it is electrolyzer or biogenic route, whichever way you look at. But one has to really get into the detail. Devil always lies in the details. Find out what is the pain point, and then look at technology. And insofar as India is concerned, alkaline is there. We have domestic companies also. BARC has developed a complete indigenized stack. On anion exchange, there is a lot of work happening at NCL. They're doing some significant amount of development, and also on the membrane there is work. AMSC that we have developed, we've done it 100% Indians. There's something in between anion exchange and a PEM. PEM is being developed here. Of course, some components are coming, and I think some components will need to come from outside, because if I'm getting some component cheaper from outside, then I might as well buy it from there. But the key components have to be done here. Solid oxide, as an example, we are now also developing the interconnect plates, the electrolyte substrate. All of that will be done here. I think that is one technology that will have the rapid indigenization, because it is at the top of the capex curve. So the opportunity to do cost reduction is much higher. So that will have almost a 98% indigenization in the next couple of years. So the opportunities are very large. The number of electrolyzers, there's also now membraneless electrolyzers. So there's something new. There's an Indian company itself which is doing that. So technology is developing as we speak. And even within the technologies that are there, if it is a PEM or a AEM or a solid oxide, in my opinion, the major cost reduction is not going to come by the volumes. The major cost reduction is going to come by engineering. Correct. My cell density is increased. That reduces the cost significantly. Then we get into the volume game, and then you really look at the demand curves that happen. Thank you.
This is an absolutely fascinating area, and I think not delved into enough. I'm sure Siddharth can take a masterclass on it, but it's actually a very, very pertinent point that you have to look at the application and then decide which is the electrolyzer. Of course, the electrolyzer has to be available and it has to be at the right cost. Whatever said and done, we are still talking about a commodity and the cost has to be less. But yes, I mean, if you're looking at a process industry where there's heat generation, then why not look at a solid oxide electrolyzer, for instance? So I think a whole science behind it, which I think we've just scratched the surface of. Bhushan, would you like to add, to this?
Surely. So I think expanding on what Siddharth said, it is not just electrolyzer for the application. There might be multiple electrolyzers for the same application. So if you look at a green ammonia plant, it may make sense, depending on the kind of RE profile you have, to have a combination of SOEC plus alkaline and a bit of PEM. So like you mentioned, we have to figure out the way to configure plants which will optimally utilize the most precious resource in green hydrogen, which is the variable RE power. You have to maximize the most of it. That will drive your levelized cost of hydrogen to the lowest level. So I fully agree that in terms of technology, we have to look at application and figure out a way to configure those specific applications, which combination of technologies make sense for them. All of these are going to coexist and in different combinations for different applications. So like everybody is aware that, alkaline is where the cost and scale is the most mature today. It is the lowest cost. And if you look at scale, people are talking about single electrolyzer of 25 megawatt itself. So that is something that is the most widespread. But if you look at other technologies, we believe that solid oxide is something that is, have a very bright future. It has a efficiency that is very, very high, going into 34, 35 kilowatt hour per kg. And it can utilize industrial process heat, which is there in processes like ammonia and steel. So once you couple that, you utilize the steam to generate hydrogen instead of making power out of it. So that gives you hydrogen at a much lower cost. So I think SOEC that way is a very, very powerful technology. Also, it has characteristics of being reversible. So you can use it for other applications. If you are having, instead of power curtailment, you can generate hydrogen and then make power back out of it. You can use it for e-fuels. Tomorrow, going ahead, we'll need, green fuels. And SOEC has that capability to generate green syngas, which can then lead to green fuels. So I think that is one technology that is likely to gain traction going ahead. The other technology is AEM. It has been there on the block. There have been some megawatt scale products that have come out, but they are still integrating a lot of small stacks into one large megawatt scale stack. But a lot of work is happening. I'm aware that, the stack size is likely to go up in the 50s and then 100 kilowatt. This technology, again, the key feature, because it is marrying both PEM and alkaline, retains the flexibility to respond to RE power part of PEM while using different materials, not going for noble catalysts. So the costs can be closer to alkaline, right? So I think both AEM and SOEC have that potential to become a very strong part of the electrolyzer mix that we will anyway need to address all the variable applications.
Well, thanks, Bhushan, and thanks for bringing out the point on the reversibility of SOEC. I think that's one point that's extremely important to note, that you can actually use SOEC on the other side also to produce electricity. I'm going to go back to AWE and PEM, because what industry is looking at right now is these two technologies, and especially AWE, which is alkaline water electrolyzers. And I'm going to talk about the integration difficulties, or is that a myth about integration difficulties? So I'm going to invite Mr. Nagarajan to speak on the subject, that how do you see the challenges of integration, both on the supply side with renewables, as well as the demand side for meeting the requirements of process industries over there?
First, thank you for inviting me, and call me Vaidya. I think that's easy for all of you. I think on the technology side, it's quite, it's on the panelist and, with everyone, it's quite clear that, alkaline water electrolysis is a very mature technology. And I think there is no second thoughts on that. But if you talk of the question that you asked, that with the load, adaptation, how it can be done, because traditionally, like Mayur mentioned, okay, AW is not a new, technology. Yeah, and I tell you from our experience, when you call Nucera, a lot of people do not know that we are also called as Ude chlorine engineers, in the past, and we have more than 60 years experience in running, alkaline water electrolysis, but for different applications, which is for caustic and chlorine. So coming back from that experience, more than 50 years, we know this technology, and that's why, Nucera was carved out from TK 3 years ago, to say that, okay, let's focus on green hydrogen with more than 50 years experience in caustic and chlorine. And then what is the differentiation is what, the madam asked about, how do you run this plant continuously? Because caustic plants has the energy, and once you start, it runs, okay, till you take that turnaround. Whereas in green hydrogen, with renewable, you have this, with the wind and solar, with the fluctuations. So what is the key expertise that we have done is the plant can run from 10 to 100%, with the availability of the wind and solar. And then how do you do that is with a digital solution, which is, advanced process controls. Okay. People in the forum might be knowing, but for people who do not know, we are building in NEOM this 2.2 gigawatt, and out of that already 800 megawatt is already installed, where, the world's, the biggest, AWE with this renewable source will be up and running by next year. And where we have this advanced process controls, okay, which will make sure with the stringent process requirement downstream can be met by running the plant, the modules, the stacks, what everyone is talking. We have Scalum, which is 20 megawatt, which will be running, because remember, each is 20 megawatt and you take a scale of 2.2 gigawatt, then, all modules cannot run continuously at the same load. So modules will be running based on, supply demand, as well as, what you get as the inputs. So the controls there will play a role. And I'll just take 1 minute, because we are talking of India here. Okay. I think India is at the moment where, as a country, we should look at big things, which is on a gigawatt level. So the scale will determine how India will beat China. I mean, we missed the bus in other sectors. And I think it's time India does it right in green hydrogen. And that will only come if you do the, the processes as well as thinking big,
So thanks for bringing up the digitalization part. I think that's incredibly important across the value chain, right from your factory of the future to integration of renewables to integration with demand. I think digital is one thing that is largely being ignored at this point of time, but needs to come in ab initio into our plans. I'm going to invite Mr. Siddharth Mayur to also add to these points. Yeah.
Thank you. I completely agree with him on this topic. But another thing that I want to bring out in terms of what for India as a country, where we are going and what we need to do, the digital infrastructure is very important, because that can determine the gross and net efficiency when you're talking about the end product. And another important area where we recently, the government has also started acting on that, is the skill development. Because if you're talking about, I was making a rough calculation, we are going to have about 6 gigawatt of electrolyzers installed in India by 2029. And the total capacity that is coming up in India is about 25 gigawatt per annum. If you just look at all of us sitting here, we are about 15 gigawatt put together. Yeah. So skill development, people who are going to actually install these electrolyzers on the ground, people who are going to maintain these electrolyzers, because we are dealing with a very notorious molecule called hydrogen. It's its own enemy. It doesn't need any other enemy. In case of solar, if you could find a local installer who knew some electrical, you could do it. Sometimes you said garam pani nahi aata hai, electricity nahi chalta hai. That was all okay. But if in hydrogen there is a wrong installation, you're talking about thousands of lives. It has explosive capabilities. So safety is something that is a very, very important area. And to teach the person how to handle this equipment, a small pipe, how it is to be fitted, how the screws have to be done, what are the process flows that are happening. So these areas, the digital area, skilling, safety, and also design. So I think what we've also experienced, and we spoke about, I think, solid oxide at length. And when we implemented India's first solid oxide plant, the design of the plant was the key on how the plant is running. So we've, even on a smaller scale, one is able to achieve efficiencies of about 40 kilowatt kWh per kg of hydrogen. And this is all due to the design part and how you digitalize things.
Thanks, Siddharth. And what I'm excited about is that while we are, having a very short panel, but all the right points are being hit. And skill development, huge, I think thrust of government of India as well. Government recognizes that for energy transition, we need a huge skilling, requirement, safety, design, all of these extremely important points. I'm wondering, Mr. John, if you'd like to add any points here.
Thank you once again. So the question was how these three different stakeholders in a system, the electricity source, the electrolyzer, and the consumer or the load, right? Consumer being the king, we need to honor it, right? And most of the consumers are needing constant source of hydrogen. Whereas on the other side, if you go by solar as an electricity input, it is fluctuating all the time. Day to night, during the day, as and when the cloud comes, it will fluctuate. So this is a challenge, how to integrate it, right? This is a question. So the way to solve it is in two parts I can see. Number one, either have a technology the electrolyzer technology which can take fluctuation on both sides. It should have that strength and flexibility, right? And we can always debate which is the best technology, PEM, alkaline, solid oxide. Some has inherent ability to take fluctuation, PEM has it. Some has ability to do it with a support system, like Vaidya told about the digitalization and control, advanced control system. So it's a matter of cost and additional system. You can achieve it. So either you have that flexible electrolyzer system, or you add on storage devices. Either on electricity side, you can add battery energy storage, or on the consumption side, go for hydrogen storage. So solution is there. It's matter of cost. The simplest and the most cheapest, or sorry, Siddharth, it's not cheapest, most economical hydrogen cost would be when you go for a solar system, no wind, no batteries, because solar is most economical tariff. You can get 2.5, 2.7 rupees per unit. Have a system which is very flexible electrolyzer. I would advocate for PEM, and then have some small hydrogen storage. I think that will give you the lowest cost of hydrogen. Otherwise, if the constant source of hydrogen is must, you can go for a hybrid system, solar, wind, and battery combination, and have a very good hydrogen storage system. You can get to meet the requirement of the customer absolutely, but the costly hydrogen will be there.
Yeah, thanks. Of course, if we have only solar, we have to worry about the utilization of the electrolyzer, which will anyway take the cost up as well. Let's delve a little bit more into R&D. Sorry. Towards the end, sorry. Yeah. Let's delve a little bit more into R&D and very, very quick points. I think a lot of points have already come out on where we need R&D. Any incremental points, Siddharth?
Thank you. So at L&T, we have a very strong R&D group in L&T Green Tech, and three areas which we are focusing on is cost, efficiency, and durability. So these are sort of straight off the curve, but then again, an improvement in one leads to a loss of performance on the other. So it's a combination of all these three that one has to work on, and the best model works. So in terms of, I think in terms of cost, it is typically the low cost materials and the catalysts, which is the primary area of focus right now, because ultimately that will have an impact on the LCOH. Second is, the sooner that we can indigenize a membrane, that will have a bearing, And the third is circular economy. So typically, if you see the stack, then I feel if we can, reuse and replenish, that means, say, after the design life, which could be 9 or 10 years, it's not necessary that we do away with that and get a new stack in place, but we replenish it or refurbish it with only the replacements which are required. So that is the first point which I would say. Second, in terms of efficiency, it is basically the catalyst, which so bringing in nanomaterials, that is one very strong area of research which is happening across the globe in this area, which definitely has an impact on the efficiency and is one primary area of research right now. Third is, one very positive thing which I've personally seen is a lot of industry academia collaboration, which is happening now, and as was being addressed today, that you have a lot of students who've come from research institutes. So having green hydrogen hubs in the premier educational institutes and sort of giving them live projects. In fact, we are also discussing at L&T with certain startups and who are based in certain educational institutions. And we find that they have revolutionary ideas which actually can have a path which can sort of change the whole course, So this is it from my side.
Yeah.
Thank you.
No, circular economy point is extremely important. Again, something that we have not yet started focusing on, but we need to see how we can leverage all the material and of course on the safe disposal and all of those things that need to come in. I'm wondering if, Mr. Bhanja, if you'd like to add on the R&D side.
Thank you, Anna. just now, actually, you told that 71% of the cost component comes from energy source and only 29% from electrolyzer. But still, this particular session is only for electrolyzer. So 29% is not less. What I want to say 29% because typical studies have seen that for electrolyzer, as an electrolyzer plant, 71% contribution from the stack or electrolyzer stack module only. Power. I'm talking about only power contribution, and 29% comes from the balance of the plant. So when you are talking about R&D required for all the aspects, like now, not only control system, the balance of the plant is having a rectifier. That efficiency is very, very important. Right now, whatever efficiency we are using with the rectifier, I think they are still less. There is some option or there some provision to improve the efficiency. Not only that, particular application wise, because when you are talking about renewable energy, even if it's solar, wind, whatever it is fluctuates. So that way, with how to get this, extract maximum out of electrolyzer plant is basically some storage is required. Now, I'm not talking about battery storage because battery storage is too costly. BESS system is much more costlier than even electrolyzer. So right now, at least that is not mature. So for grid storage, you have to think. So if grid you are using as storage, so the issue is there has to be a bidirectional rectifier, which can because from solar you are getting DC, from it has to be connected to grid, so we have to convert to AC. So it, and again we are using the rectifier, electrolyzer, again it is DC only. So that efficiency of that particular conversion is also very, very important. So lot of electrical energy or electrical inputs or R&D can be are required for this conversion of this grid to this solar and solar to grid. So there are a lot of R&D is possible. Now, other than this, balance of the plant is also very, very important. So that is a big component for what is the final quality you are talking about. That is also important. One more R&D is possible. What is the operating condition? What is the operating temperature, pressure, etc.? You'll be surprised to know that optimum this operating pressure is around 30 to 50 watt. Rather 30 watt is it is shown that so many studies are done. Operating optimum is 30 watt pressure. Lower the pressure, efficiency is less. Higher the pressure, again efficiency is less. I'm not going to technical things why it is happening, but it is true. There because there are two. One is streaming effect is there, another is bubble size because number of gas amount of gas reduces with pressure. So that way the operating condition also lot of R&D is possible. So how to operating parameter, how to choose at what point I should operate this electrolyzer.
Thank you.
Inherently, this whatever alkaline PEM is having little bit higher range, but alkaline also quite flexible. It can be connected with any renewable energy. That is not a problematic, and it is ramp down is quite fast. So there is no issue about that. And rest of the R&D, whatever is required, let us come to cell. Main R&D is required. If it is a PEM type of electrolyzer, our most focus should be development of indigenous membrane. This is really a lot of scope of R&D is there that is required, and somebody has done it in the physically in this world, so it can be done here also in India also. So a lot of R&D is possible. That we should focus on that kind of R&D for PEM development. And there are other type of things because we can think of some point of use electrolyzer that is also possible when electrolyzer most efficient when it is used in the point of use where we're using the solar energy or renewable energy producing hydrogen using at the same like community kitchen, that kind of thing. That is also good place where a lot of R&D is possible.
Thank you.
And safety, of course.
Yeah.
Safety
Thank you.
Thank you.
Yeah. So, I mean, very, very quickly, Mr. Nagarajan, if you have any incremental point to add, like just thank you.
No, thank you. There is a lot of points, but I know there is a time constraint. So I will only say that quickly, the global, as Nucera, that 50 years what we are talking, our focus is mainly on the R&D focus is how do you reduce the cost and then improve the durability. I mean, there are a lot of studies being done and we are implementing in the customer premises, but of time constraints, but I'll quickly go back to what Mr. Bhanja said, that, right? I think there are two key factors that has to be looked into that. Okay. One is as a technology, which is the mature technology that has to be done. And in that, okay, what has to be done, to reduce the cost, because the 71-29 again is important. You have to look, but stack is 71%. And we being the technology leader in stacks, we are focusing on that. Of course, sir, we took care of what you're saying that, but our focus as Nucera is to focus on how do we reduce the cost in the stacks. Thank you.
I can't help but add one point there that 71-29, that difference, that proportion is there because of the efficiency of electrolyzer. So finally, it's not only the cost of electrolyzer. If we work on the efficiency, then automatically the renewable energy required to produce the same amount of hydrogen becomes less, and that ratio will change.
So that's exactly what we are working on. That when you say that the energy consumed, hours, the scalum, I can go back and talk about that in details, is one of that where we work on how do we consume less, energy to split the molecules.
I think that's a very, very key point, other than cost, and Siddharth will be happy that we have moved away from cost. So the final question is on policy and ecosystem. So finally, a lot of great work happening by the industry, very, very enthused and energized to hear, the extent of deliberation, that's really going on, and efforts as well, not only deliberation. Mr. Kashalikar, from the government as well as the industry standpoint, what are the critical policy and ecosystem enablers that are required?
Yeah, so I must admit a lot has been done with the PLI, site, etc. But this is a challenge because we are ahead of the curve. There is no demand. Otherwise, the market forces take charge of everything. It becomes competitive. The best players survive. For that, two things. One, demand. We have tenders almost 1 gigawatt. Siddharth mentioned already we are sitting 15 gigawatt capacity here, and there are a few more there. So demand. I believe oil and gas industry is well positioned. They have handled hydrogen for 30, 40, 50 years. So they know the safety, everything they know, There we can do a little more on demand. Second is looking at other countries, these are new developments, especially MSME is finding it very difficult to attract bank credit for new plants. And the reason again is no demand or no past, references. So both these solutions could be addressed. US, of course, the Department of Energy is guaranteeing the loans of hydrogen projects. So there's no corporate guarantee. Now we can probably offer a corporate guarantee, but in MSME that becomes a challenge. So these two are the two areas: demand driving and credit for hydrogen projects. Thanks.
Very fair points. Mr. Chitale, Bhushan, would you like to add?
I think a couple of points that I can add is, one is regarding, you have to look at supply chain from a overall value chain perspective. So within stack, like the panel discussed, it is mostly around, say, membranes and catalysts. If you go further towards balance of plant, most of the fabrication items, it's a question of scale and demand. We already have those capabilities. Maybe hydrogen compressors, if you go further down below, So we have to identify and maybe look at a center of excellence approach that, for membrane, it has to be a partnership along with government and industry and academia, that we create center of excellence, which either uses the existing technologies and improves upon them so that the entrepreneurs can lease and license and manufacture based on those. So that approach will focus attention on critical areas of supply chain, which are lacking today. And we have time. Maybe it will take 2 years, 3 years to develop this. But this will help in building supply chain in areas where there is no genuine Indian options. And second, I think one approach which we have seen elsewhere in China and all is that, it's an ecosystem that gets created where similar vendors are co-located and they're supplying to multiple manufacturers. So your bipolar plate or electroplating of the electrodes, that not everybody has their own. It is done by common set of vendors for different OEMs. So looking at a industrial park kind of approach where you give incentives for these component manufacturers to base their operations, maybe some interest rate subvention, easier credit, so that they are able to scale. And once they are able to scale, they can support multiple specs of different vendors and drive down cost and improve efficiency. So that kind of approach will help grow the component base and the ecosystem there.
Great points. I'm just wondering, as a last comment if anybody would like to add to the policy and ecosystem side. Otherwise, we'll move to the audience. Yeah.
Good. I think if you're looking really at the policy, one key thing that, at least from the industry standpoint, is that if 80% of the policies announced, if they're just implemented on ground, I think we are in, we have a home run, literally.
True. I think that's excellent last words to end the panel with. Maybe we can just take a couple of questions from the audience. With this gentleman wanted to come in, so please. Please introduce yourself.
Chakradhar, Demex Green. When you talk about optimization, Siddharth Gupta ji knows about of productionizing large components like how Mitsubishi does. But you typically commodification is the strategy for productionizing, so that it will go against scale. So I don't know if the panel wants to comment about that.
I am Dr. Raghu Prakash from Parishkar College, Jaipur, and we are doing a lot of things in green hydrogen, training, research, and all that. Do you, all of you, anyway, some people mentioned about it. Do you have any specific program to align with academia regarding R&D? We are very much willing to participate in that.
There definitely are programs aligned to that, which includes, I spoke about skill development. There is also a program linked to development of balance of plant components or even processes. And I think what Siddharth also mentioned is that there is so much talent available, and you can be, second that. So these, the younger generation, if we can propel them, and I was at a college in Pune the other day, talking to the first year chemical engineering students, and everybody said that we start internship in the third year, we start internship in the second year. And I said, why can't you write a patent in the first year? So we as an industry also need to come forward, and I've done that to this school, and I said that whoever has an idea, come to me, I will dedicate the weekend. My factory is open even on Sundays. So I will dedicate the weekend. You can come there. I will give you specific pain points that I have. Work on that, and I will not give you the stipend that interns get, not 100, 200 rupees. I'll give you a decent stipend, and you will not get a certificate just because you're an intern. If you have worked, you'll get a certificate. And if you start that from first year itself, so by year 2 or year 3, they would have probably solved 50% of the problems we have mentioned here right now in the panel. And two such ideas that came through, I cannot mention them because they're still under process, but in that talk, there were two children who came, 18-year-old kids. And this boy gave me some idea, which in the last 15 years of my work on green hydrogen, I've never thought. So I told him that come to office and, we'll do this. So this is something that we as an industry also need to come forward. And even the academia needs to then tell your students, interns should not be just for the marks. Interns should be for real work.
We have 3 years and 4 years BSc green hydrogen course and MSc green hydrogen courses.
Thank you.
Yeah,
Thank you.
this is the first in India.
I think, Siddharth, I'm very impressed by what you said. I'm reminded of Salvation in Netflix, where MIT students are collaborating with billionaires. Okay, yeah, next question, please.
Just madam, can I say about this scale
Yeah,
up?
Sorry, I
You
think
was
that
telling,
got left.
So,
Yeah.
Sir, what is issue is when you are talking about scaling up or this kind of manufacturing, if I increase the optimization when you are talking about, if I scale up, electrolyzer scaling up, it is not going to cheaper. It is going to maybe costlier. Say because it is anyway modular, and if I want to scale up, my diaphragm size will increase, your electrode size is increase. Actually, it will increase the cost, but balance of the plant will be saving. So overall, if you say electrolyzer plant cost maybe 55, 45, that kind of breakup. So maybe electrolyzer cost little bit it can increase. The overall cost will be reduced, but not much because the electrolyzer cost increases if I scale up and balance of the plant decreases. That rate may be equal.
Yeah, so you're actually scaling up, so you're getting into higher module sizes. So in terms of the higher stack size also, so ultimately the denominator increases. So in those terms, scalability definitely will have an impact as you go in for higher stack sizes, which correspond to higher module sizes. So, but right. So ultimately, no, your question is very valid. Ultimately, see if entities are planning to set up gigafactories, which we are doing, which we are in the process of doing, then we have to look at those options. That how does it work? Because what you're talking about is a repetitive line of action, and ultimately stack is what stack is on similar lines. You might have 107 components, but if you generalize it, you'll have 5 or 6 components. So it's possible to do that, but these are different ways of how a manufacturer would like to integrate that. That's right.
Yeah.
So demand and offtake. So and that is where, if there was a consensus amongst practically everyone, that is where the whole thing lies as far as today's scenario is concerned.
Thank you. I think we will probably have just time for 1 or 2 questions, and organizers can tell me. Yes, please, the lady.
Hello, hi. I'm Akansha from Argus. My question is for Thyssenkrupp and L&T. So I already know what is happening with John Cockerill and Ohmium about the factories. So I just wanted to ask, could you shed some light on the progress in India about your plans in India?
L&T.
Thyssenkrupp and L&T.
Thyssenkrupp and L&T. L&T has the mic. Okay.
So I want him to answer first,
So we throw each other, but coming back to the manufacturing, just to give the background, Thyssenkrupp is well known, and like I said, we have 50 years experience in that. But Thyssenkrupp Nucera carved out, from Thyssenkrupp 3 years ago or 2 years just to focus on green hydrogen. We have our facilities in Europe, and and the market, as all of us are talking, are quite mature in US and Europe. India, we started last year as as engineering functions which supports the global and things. Manufacturing is on our radar, but the timelines are yet to be defined. I can only answer that at this point of time. Yeah.
Thank you, sir. So from L&T's perspective, our manufacturing facility is ready, and we are going to commission it in the next, I would say, 10-15 days for the stack assembly as well as the EPU. And we already have sort of 2.5 megawatt stacks, which we have assembled here indigenously. And the EPU, the electrolyzer processing unit, has also been manufactured and assembled here in India, in Hazira, in fact, and is operating in a green hydrogen plant. So that was effective, say, 1st March 2024, which was a big day for us because that was the first unit which we did here.
And just to add to what you're saying, that there should be a demand, then supply comes. Just to answer, I think that's what we are talking here.
Thank you.
Thank you.
Last question, and a very quick one with a quick response. Yes.
Thank you very much. Good afternoon. My name is Rohish Kalwit, and the question to all of you is, since you are into manufacturing of the electrolyzers, and we have been talking about China and the missing of bus and such things. So in terms of costing, again, back to it, the heaviest component of costing in an electrolyzer project or in any hydrogen generation project would be the RE power, right? And then the utilities. So you, as a collective group of manufacturers, what would you say that to make green hydrogen a successful story in India, what policies or what kind of actions would you suggest to the government or to the market? Thank you.
So I have a background in solar, so I can probably throw some light. See, to show the economics, today, if you ask anybody at what cost you are ready to buy hydrogen, most of the people, green hydrogen, they will say $2, because that is how I can produce hydrogen with natural gas, right? So $2 is a target. Unfortunately, across the globe, green hydrogen is in the range of $4 to $7. So there's a gap, right? But let us understand why that $4 to $7. It is depending upon the geographical nature, availability of sun, etc. In India, it is possible to do at 4. That's why this 4 to 7 is coming. Now, question 4, can it come to 2? And I believe yes. And in your question is the answer. It is all dependent on the renewable energy cost, right? Electrolyzer, even if you give free, it doesn't have much big impact when compared to renewable energy cost impact. Now, $4 is possible with electricity cost of 4 rupees per unit, because you need probably batteries and some wind hybridization along with solar. If you remove some of the BCDs and others, which is there today, almost like 40% on the solar modules, number one. Number two, if you have a dollar denominated contracts, these two things can immediately drop down the cost of electricity. At least the solar cost will come down from 2.7 to 1.5, right? And the battery, the way it has come down the cost in the last 1 year, it is nowadays it's available at less than 1 rupees per unit per hour. So mix of it can reach the 2 rupees per unit target of renewable. And if you reach 2 rupees per unit, you can hit $2 per kg. It's very much possible, practically possible in the next few months. Some of the policy and industry has to be willing to take it on. We will be there.
Thanks. Thank you. And with that, we will end the panel. Very delighted to have 15 gigawatts of manufacturing capacity in this panel. And we are really looking at you to make this happen. Very, I think deep points that came out on opportunities. We have a very large market over there. So there is a promise of a domestic demand, of course, exports. We have strengths such as a very large MSME base with processing capabilities, which we need to leverage. We have the capability to also do local production, but of course we need to work of components, but we need to work with the vendor base to get their capabilities up. Some of the challenges we spoke about is especially indigenization and aspects such as diaphragm, bipolar plates, to some extent improvement of efficiency of balance of plants. We need more R&D efforts in this area. Financing has come across as an important point where we definitely need focus to bring lenders on the table. Some of the enablers that's required is industry, academia, government, collaboration, especially on things like safety, skilling, R&D. We need to look at addressing integration issues to begin with storage, both on the supply side as well as the demand side. Digital applications, again, become a very, very key enabler when you're looking at integration. Lots of other points being made. The most beautiful point was we are so entrepreneurial. I think we will come out at the top and we will become a big, big manufacturing hub for electrolyzer in this world. And with that, thank you to all the panelists and thank you to very much.
Thank you so much, Mrs. Anvesha Thakker, for moderating this entire session so wonderfully. We could all feel the green energy actually flowing in the room, of course, with our session. Thank you very much once again, and thanks a lot to our eminent panelists, and we would like to honor them with the mementos that we have. And I would like to request Mrs. Anvesha Thakker to do the honor, and I would request the mementos to be brought to them. I would request Mrs. Thakker to honor Mr. Shekhar Kashalikar with the memento. To Mr. Siddharth Gupta. To Mr. Siddharth Mayur. To Mr. Bhushan Chitale. To Mr. Kalyan Bhanja. To Mr. Shaji John. And to Mr. Vaidyanathan Nagarajan. I would like to invite on stage Mr. Anubhav Uppal, scientist, MNRE, to honor our Honorable Chair, Mrs. Anvesha Thakker, with a memento, please. Can we have it for the photo opportunity, please? Can I request all the eminent panelists as well as our Honorable Chair to please come forward for the photo opportunity. There may be many obstacles, but it's